Okay, so let's do some examples of a rock and I rock. So here is a function, x squared minus 5x plus 4. And the first thing we're going to do is find the a rock and a couple of I rocks using the definition. So first of all, a rock. The definition of a rock is f of b minus f of a all over b minus a. So you'll always be given an interval over which to find that a rock. And that a rock goes from 1 to 5. So in this case, it will be f of 5 minus f of 1 over 5 minus 1. And of course, you would find f of 5 and f of 1 by plugging them into the function. When you plug in f of 5, you get 25 minus 25 plus 4, which is 4. When you plug in 1, you get 1 minus 5 plus 4, which is 0. And then 5 minus 1 is 4. So the a rock on this is 1. That means the slope of the secant line from 1 to 5 on the graph is 1. Now, part B. Part B says find the I rock, which means you want the slope of the tangent line at x equals 3 using the a definition. So here's the a definition. So the limit is x approaches a of f of x minus f of a all over x minus a. And in this case, a is 3. That's the place we're trying to find the a rock. The I rock. So we'll let x approach 3. Now, f of x is what you get when you plug x into the function. So that's going to come out exactly the same as what the function looks like. It's x squared minus 5x plus 4. Minus f of 3 is what you get when you plug 3 into the function. So that would be 9 minus 15 plus 4, which is negative 2. Now, I'm going to simplify this. So the limit as x approaches 3 x squared minus 5x plus 6 over x minus 3. And I want to find what this limit is. So this limit, if I plug in 3, I would get 9 minus 15 plus 6, which is 0 on top, and I get 0 on the bottom. This should always happen with I rocks, because when you plug the number in, essentially what you're plugging in is 3 into the thing that's approaching 3. So you should be getting the exact same thing from those two things. So you're always going to get 0 over 0. That's really why we learned how to deal with 0 over 0 forms earlier in the chapter. So this is polynomial over polynomial. So I'm going to take this and I'm going to factor the top and bottom. The x minus 3's cancel. Now I can resubstitute. And in this case, I get 1. So it happens that the slope of tangent line at x equals 3 is 1, meaning it's parallel to that secant line we had earlier, right? Same slope. So for part C, we want to find the I rock again at a different value, 6. And we're going to use the h definition this time. Now, I think in the last video, I wrote this as the limit as h approaches 0 of f of x plus h. Really, we want to use a plus h because a is the fixed point at which we're trying to find the I rock. So the f of a plus h minus f of a all over h. So if you want to, you can go ahead and change that in the previous video's notes, because I did make a mistake when I wrote that down, I think. So in this case, my a is 6. So this is going to be the limit as h approaches 0 of f of 6 plus h minus f of 6 all over h. And again, f of that thing means we're plugging it in everywhere we see an x. So f of 6 plus h would be 6 plus h squared minus 5 times 6 plus h plus 4 minus f of 6, which is what we get when we plug 6 in. So that'd be 36 minus 30 plus 4, which is 10, all over h. So there's some simplification to do here, because if I plugged in 0 for all the h's, you would see very quickly you get 0 over 0 again. And again, that should always happen when you have an I rock. So what we're going to do here is we're going to go ahead and multiply this thing out. So I would FOIL out the first set of parentheses there, so that would be 36 plus 12h plus h squared. Then distribute that negative 5, so negative, not 60, but negative 30, minus 5h, plus 4, minus 10, all over h. Now, because we know that an h is going to have to cancel on top and bottom because we got 0 over 0, we're going to look at all the things that don't have h in them. So have 36 minus 30, which is 6, plus 4, which is 10, minus 10, which is 0. You see how all of those things that didn't have h in them went away? That should always happen when you're doing this definition. Again, because you get the 0 over 0, we want an h to be able to simplify away. So now I'm going to combine like terms. So that'll be h squared plus 7h all over h. And now I can factor out the h on top, simplify, and now I'm ready to find this limit by plugging in 0 for h. And I get 7. So this 7 is the slope of the tangent line at x equals 6. Now, I will leave you to do parts D, E, and F, although we can talk about D really quickly. D says which is growing more quickly, x equals 3 or x equals 6 for this function. So obviously you're looking at a rate of change, and the bigger the rate of change, the faster the growth. So the rate of change at x equals 3 was only 1, the rate of change at x equals 6 was 7, so the bigger one is at x equals 6. Now, E and F are simply writing equations of lines once you have slopes and points, so I'm going to ask you to do that on your own before you come into class next time.